Hi, in 5.3 we're looking at solving systems, but instead of graphing this section like we did in 5.2, we are going to use a process called substitution and also the process of addition or subtraction, which you may have heard is called elimination. So when we want to solve by substitution, what we want to look for here is a coefficient of a positive one within our system. So we want to look for a coefficient of 1 within our system. So when we look at the system here, we can see that we have a coefficient of 1 right here. So now what we want to do is get that variable isolated, which means I'm going to take that negative 3y and add it to both sides, so I have the x by itself. So I'm going to get x equals then this 3y plus 6, or 6 plus 3y. Then what I'm going to do is take this expression and substitute it in for my x. That's why it's called the substitution method. So now when I write that, I have 2 times this 3y plus 6, and then I bring the rest of that equation down. Plus 3y equals 3. You always want to make sure that when you substitute this in, you always put it into the other equation. If you substitute it in the one you just brought it from, everything's going to cancel out. So now we have to distribute. So we get 6y plus 12 plus that 3y equals 3. Now we just need to solve this equation for y. So we get 9y plus 12 equals 3, and then we're left with 9y equals a negative 9 to get y equals a negative 1. So now that we have one of our variables solved for, we need to find the other. So what we're going to do now is take this right here, that negative 1, and substitute it back in for y into either the first or the second equation. At this point, it doesn't matter which one you choose. So I'm going to substitute it into, we'll go with the first one. So we have x minus 3y equals 6. So again, I'm taking this negative 1 and I want to substitute it in for our y. So we get x minus 3 times that negative 1 equals 6. To continue solve this, we have x plus 3, subtract a 3 from both sides to get x equals 3. So now we have a solution of 3, negative 1. Again, that point there is what we call the solution. And what you should always do is substitute your solution back into both originals to make sure it makes both of them true. Okay, now, example 2. What we're going to do now is, this is actually the same system from above, but we're going to solve it using the process of addition or subtraction, or maybe you've heard it called elimination. So now when we are solving using addition or subtraction, what we want to look for here is a pair of opposites within one variable. So we want to look for a pair of opposites in one variable. For example, 5x, 5x, and a negative 5x. Those would be opposites within one variable. So now, first thing we want to do when we look at our system, you just want to double check that it is in standard form. This will need to be in standard form in order to have everything line up correctly. Now that we notice it's in standard form, we want to look for a pair of opposites. Right, and our pair of opposites here is going to be this negative 3y and that positive 3y, because negative 3 plus 3 would be 0. So once we have a pair of opposites, we need to add these equations together. So I'm going to write that here. Once we have opposites, we want to add the equations. So we are going to take this x minus 3y equals 6 and add it to this 2x plus 3y equals 3. And then we're just going to add up our columns how we would add in a regular old-fashioned arithmetic problem. So here we have a 1x plus 2x gives us a 3x. And then a negative 3y plus 3y. That's going to cancel or just give us a 0. 6 plus 3 is 9. Well, 3x plus 0 is 3x, and then we're left with x equals 3. Now, once we solve for one variable, we can take this value here and substitute it into one of the originals. So I'm going to use the original, 2x plus 3y equals 3. So again, I'm taking this value here, and now I'm going to substitute it in for the x. So we have 2 times 3 plus 3y equals 3. Go ahead and pause the video and then solve for y, and then write your solution. Okay, and you'll notice that when we substitute it in, we solve, we get y equals negative 1. So we write our solution as an ordered pair, 3, negative 1. Okay, so example 3 says solve the system by using elimination. Again, we want to look for a pair of opposites, but we'll notice here that we have 1x and a 2x, not an opposite. Negative 1 and negative 3, also not an opposite. So what we have to do is create a pair of opposites. So if I look at the x's, we'll start with those. If I look at these, I see that they are not opposites. However, what can I multiply this x by, or a 1, what can I multiply a 1x by that'll be the opposite of a positive 2x? Right, a negative 2. So I want to distribute a negative 2 to both sides to create opposites. So I'm going to write the original, so x minus y equals the 3, and I'm going to distribute a negative 2. So I have negative 2x plus 2y equals negative 6. Now I'm going to bring down my other equation, which was this 2x minus 3y equals negative 1. Now you can see I do have that pair of opposites. So now you can add them together and then solve the problem. So what I'd like you to do now is pause the video and finish this problem. Okay, we get the solution of 10, 7. Again, solutions should always be written as an ordered pair, which means you need to have parentheses around both of your numbers. Okay, moving on to example 4. Solve the system using any method. So what I want you to do now is you can either solve the system using substitution or you can solve it using elimination. I'd recommend pausing the video, solve it on your own, check your answer, then play the video and check it with mine to see how you did. Okay, we get a solution here of 6, 0. If you didn't get it, pause the video, look back at my work, see if you can find your mistake. Maybe you used the elimination method to solve it, which is also okay. If that didn't work, you could try the substitution like I did it. Okay, example 5. This one's going to be very similar to the last problem we did in 5.2 because we have to set up the systems now. So entering Yellowstone National Park costs $25 for a car, $20 for a motorcycle. One June day, 5,950 cars or motorcycles enter and pay a total of $137,625. How many cars and motorcycles entered? So just like we started the problem in the last section, you have to start by defining variables. We need an x and a y. And I'm just going to let my x be how many cars and my y be how many motorcycles. Now, I want you to pause the video and set up your system and then unpause it and check it with mine. Okay, if we know that when you add up the cars and motorcycles together, 5,950 vehicles entered, so we just want to take x plus y equals 5,950. Then we have to look at the dollar amounts for all of these. It's 25 for a car, so 25x, 20 for a motorcycle, so 20y, equals the total amount of money. So now that you have two equations to create a system, You can now solve to find how many cars and how many motorcycles. Again, you could solve this any way. You could use elimination or you could use substitution. So go ahead and pause the video, pick a method, and solve this. Okay, I chose to use the elimination method here since in the previous problem I used substitution. So I used elimination, which means I distributed, in this case, a negative 25 to my first equation. You also could have distributed a negative 20 to the first one, and it would also have worked just as well. When we solve that, I find my y, substitute my y back in to find my x, and then I find my solution. Okay, this next one. A 150-meter cable is cut into two pieces, such that one piece is 4 times as long as the other. How long is each piece? Again, first thing we want to do is define our variables, x and y. Well, here we're just talking about two pieces of a cable, so I'm going to let the x be my first piece and my y be my second piece. I know together they make 150 meters, so x plus y equals 150. Now, for my second equation, it says that one piece is 4 times as large as the other. So I take one piece, it wouldn't matter which one you choose here, and let it be 4 times the length as the other. Now, we can solve this. This one's set up nicely to use substitution because we already have a variable solved for. So we simply just need to take this 4y and substitute it in for x. So go ahead and solve this system. The solution I got here is 120, 30. Okay, that's all we have for section 5.3. Please reach out with any questions.